Introduction to Computer Memory by Ebony Richardson. When you think about it, it's amazing how many different types of electronic memory you encounter in daily life. You already know that the computer in front of you has memory. What you may not know is most of the electronic items you use every day have some form of memory also. Each of these devices uses a different type of memory in different ways. Although memory is technically any form of electronic storage, it's used most often to identify fast, temporary forms of storage. If your computer's CPU had to constantly access the hard drive to retrieve every piece of data it needs, it will operate very slowly. When the information is kept in memory, the CPU can access it more quickly. Most forms of memory are intended to store data temporarily. By the way, here are some quick terms that you should become familiar with before we continue, as they may appear often throughout the presentation. As you can see in the diagram, CPU accesses memory according to a distinct hierarchy, whether it comes from permanent storage, the hard drive, or input, the keyboard. Most data goes in random access memory, RAM. The computer then stores pieces of data it will need to access, often in a cache, and maintains certain special instructions in a register. Fast, powerful CPUs need quick and easy access to large amounts of data in order to maximize their performance and run smoothly. If the CPU cannot get the data it needs, it literally stops and waits for it. Therefore, to make sure every process runs quickly and smoothly, a typical computer has Level 1 and Level 2 cache, normal system RAM, and virtual memory, and also a hard disk. System RAM speed is controlled by bus width and bus speed. Bus width refers to the number of bits that can be sent to the CPU simultaneously, and bus speed refers to the number of times a group of bits can be sent each second. A bus cycle occurs every time data travels from memory to the CPU. Caches are designed to alleviate this bottleneck by making the data used most often by the computer instantly available. This is accomplished by building a small amount of memory, known as primary level 1 cache, right into the CPU. Level 1 cache is very small, normally ranging between 2 kilobytes and 64 kilobytes. The secondary level, or level 2 cache, typically resides on the memory card located near the CPU. The level 2 cache has a direct connection to the CPU. Depending on the CPU, the size of the level 2 cache ranges from 256 to 2 megabytes. For more information on this topic, please visit howstuffworks.com. This is the credit for the presentation. The end.